Joining us on the podcast today, we have Kristie Mann, who goes by many titles, but I think Queen of Persistent Memory for Intel is the correct one. Kristie, thanks for joining us.
I love that one.
Yeah, I think that's a good update for your LinkedIn profile. Gosh, it's been a while since we've seen each other in person, and we have to do this remote again. But the last time was, I think, was when you were launching Persistent Memory back in April of last year. I can't even believe it's been that long, but the product's been out there for a while now. So just maybe give us a sense. Actually, before you give us a sense on the update on Persistent Memory, just take one step back for those that may not be as in tune with what you're doing with persistent memory and set the table for us.
Right, that's a great place to start because it's still, it sounds like a long time, last April, but we really haven't been in market that long, so I'm sure not everyone is fully aware. So persistent memory is a new technology. Like we said, we launched it last April. It's a little bit like memory, it's a little bit like storage, and then I always add it's unlike both. And that sounds like a funny description, but what it really is we take the Optane technology or the media. It's the same media that's used in our solid state drives. We call them the Optane SSDs, and we package it into a memory DIMM form factor. So it's electrically and physically compatible with DDR as the protocol. It looks like a DIMM, smells like a DIMM. It is byte addressable like a DIMM, which is what makes it incredibly unique when you compare it to storage technologies. But it has the capability of being persistent even when power is lost. So it's much more like storage from that aspect. So you take all these
Right.
elements that are a little bit like memory and storage, you put them together in the compute block, and that's what persistent memory is.
Well, I know when we've done a little bit of work with the first generation modules already, and we were looking at more enterprise use cases, databases, things like that. Now, out of the gate, though, persistent memory can work in a couple different ways, and I know that was one of your big points of education early on because it was different, right? The persistence of storage in the memory form factor, but interacting with it was different too. So how has that changed over time? And are you seeing applications become more aware of persistent memory in terms of how they're interacting with it? Because I think that was always the dream, or that's been the dream of many disruptive technologies over time, going back to maybe what Fusion IO was doing with edge cards back in the day. They had this high speed solution that was available that wasn't existing before, and their hope was always that applications would take advantage of that uniquely. And I don't know that dream ever came all the way to fruition, but with persistent memory, it seems like it's worth the effort. So I'm curious how that's going.
Yeah, that's a great question. So I think I'll start by just refreshing everybody's memory about the fact that we consider persistent memory almost a solution on a DIMM, meaning that it consists of not only this media that we talked about, it consists of a controller that lives halfway in the processor and halfway on the DIMM itself. There's a protocol involved, and then there's that software piece that I think you're touching on, which is the application aware of persistent memory? Does the operating system know what to do with it? So there's a whole ecosystem play that's required to make sure that we get adopted. So as I step back and think about why is that software optimization important, there are multiple modes in this solution on a DIMM that we talk
Right.
about. There's memory mode, and then there's what we call app direct mode. And I want to explain the differences between the two. Memory mode is used, it's transparent to the application, the operating system. So it means you can take the device, you can plug it in, and you can use it like memory. You can talk to it like it's memory. The system doesn't know the difference. At this stage of the game, though, it doesn't have the capability to be persistent. And so it's basically a volatile pool of memory. DRAM that's in the system is used as a cache for that pool of memory. So it's great for getting to try the capacity benefits, but you're not seeing the true benefit of the technology until it's been application enabled and to run in app direct mode. And in app direct mode, now the DRAM is a separate, distinct pool of memory that can be used for the super hot data. The persistent memory can be used for capacity, and the application chooses which pool of memory to use. So it places the data more intelligently than that controller could do that I mentioned that's in the processor and on the DIMM.
Okay.
Um, so how are we coming with all of that? I would say we have more than 30 applications, and all of the major operating systems in the data center market are persistent memory aware, or even, dare I say, optimized for persistent memory.
Ooh.
Yes.
Okay.
And then I see that growing every day. There's all sorts of new software. We're maybe even going to talk about some of them today that are developing with persistent memory in mind. So I see it growing. I think Intel is uniquely positioned because we're not an ISV, we're not an OEM. We are just deeply integrated into that ecosystem fabric, so that we've been working the last 5 years with some of these ISVs to make sure that they're ready.
Well, how much education do you still have to do there? Because it is a new product, even though it's been a little over a year. But you're the only ones out there doing this. So it's not only do you have to educate about your product, but you have to do the market education too of all the benefits of this technology and why you should care. And it comes easier probably in some markets than others. But how is that to go make the market and then go sell your product?
Yeah. Well, it's hard. So I'm not going to lie. It's always hard to establish a new product category. And I think the biggest problem isn't the lack of education, it's the status quo mindset. So for 50 years, developers and designers have designed their software applications so that they had to make a trade-off between expensive low capacity DRAM or high capacity low performance storage. Um, so given that that's changing, just getting people to understand that it's changing and that they need to be ready, that is the piece that we've got to drive that market awareness and the education. But then once we find that customers are seeing the value, they're willing to invest in the optimization, and it's not a hard optimization. We've made all of it open source. You mentioned you guys are the only one doing this. Well, persistent memory programming is actually designed around the SNIA standards body
Sure.
for persistent memory programming. It applies to NVDIMMs. It'll apply to a lot of the future-looking standards. So we're not the only ones out there, but you're right. It's a long journey. If you look back at NVIDIA with CUDA, it took them a good 10 years before that was an acceptable, programming language. So we're taking a bite of the elephant each day, but it takes time.
Well, you're right. I mean, we've seen companies probably for the last 10 years, similar to CUDA, that have been trying to figure out how to get something into the DIMM slots to offer high performance storage, but they've always come with a compromise, and normally it's a design compromise. I mean, the number of battery pack add-on things that I've seen that are Frankenstein technology to make that work and then give the power to hold up the DRAM in the event of a failure or a reboot. I mean, it's asking a lot in the enterprise to put more complicated server gear on the floor than you really need. And there probably are some spots where they're willing to take those chances, but the way this is productized is just a drop in where you really don't have to do much of anything from a system design perspective, or even from a ongoing maintenance perspective once it's on the floor. I think to me is why I really think of this as a lone product and not competitive landscape with all the other NAND fab guys out there with solutions. So that's and it's a sophisticated solution too, as you said. That you can't diminish the fact that the Optane technology underpinning the storage component of this is pretty strong too.
Yeah, yeah.
So it's interesting though, as you talk, listening to you talk about architectures and applications. It seems like we've gotten so used to on the storage side of the concept of tiering, and it's
Hmm.
since flash has come along, it's been sort of fundamental, right? We're going to put a little bit of flash in front of the 10K hard drives, and then the flash got bigger and faster. And now we're putting flash in front of flash. In fact, we just posted a piece yesterday around an Azure Stack HCI solution using Optane 750 gig Optane SSDs in front of 15 terabyte QLC drives. I mean, the stacking available now in these systems, when you're putting 15 terabytes in a 2.5 inch port on the front of these servers, is amazing. And now if we want to get really fancy in Azure Stack HCI anyway, we can put persistent memory in there too and have a three-tiered architecture to make sure you're driving all the performance that you can while still picking up, if you have to go to the QLC, reasonable performance, better than a hard drive, of course, and then all the other benefits of Flash and the TCO. And I don't have to tell you, but are you seeing, like, is this three-tier concept? It seems intuitive, but I don't know. Are you seeing that out in the wild?
We are, and I love the fact that you're thinking about it in terms of tiering, because as you talk about this concept of where persistent memory fits, it doesn't replace any of the available devices and hardware today. It's an additional tier. And we see traditionally when you move between tiers, you get 10x the performance benefit, or you get 10x the capacity if you're moving down to the higher capacity devices. So this is exactly how it plays in my mental framework as well, and we're seeing it across the board. I would say that it's interesting of what you call this tier, because now it's not necessarily a storage tier; it could be a memory tier. And in the HCI example that you gave, the PMem is being used as a new memory tier for memory capacity to bring more data into the compute block. And then we look at companies like Oracle Exadata, who have implemented persistent memory as a tier in their database machines. And in that case, it's being used as more of an incremental storage tier. So
Right.
there's a lot of creativity that goes into each of these instantiations of customer deployments. But yeah, I love that tiering framework that you laid out. That's exactly it. It's a third tier.
Uh, I love that you're calling it PMem now, because I think at the launch, Intel, likes to be very focused and determined to make branding their own. And PMem
Yes.
was one that I think we fought on a little bit over time, but it's easy, and the industry pretty quickly went to that, and the server guys started talking about that. But I think it makes it easier. It rolls off the tongue, a nice four letters. It's easy to get behind.
Yeah, I loved our initial branding team's recommendation. It was the Intel Optane Data Center Persistent Memory. I was like, boy, that just rolls off the tongue, guys. So
Yes.
yes, as we've gone to the second generation, and we're now moving along with our 100 series and 200 series, life got a lot easier. We're just like, come on, guys, it's persistent memory, it's PMem.
Well, in this series, branding aligns well with what you guys have done in the past on storage, and so it sort of fits. So you brought up the 200, and now the original is the 100 series. So the 200 you launched recently. Why don't you talk a little bit about what you're doing there, and what the second product does for you?
Right. So as you know, anytime you're in a new technology category, your first product is what we call an MVP,
Mm.
minimum viable product. And so our code name Barlow Pass, we call that the 200 series, that we just launched it in June with some great improvements based on learnings from our first generation. The first thing we were able to do is on Cedar Island, which is the Cooper Lake based system or platform that Intel just launched, we're able to achieve on average 25% better bandwidth. And we're able to do it at approximately 3 watts less per DIMM. So I don't have to tell you how that can add up over time in your data center. The power savings alone is huge. So it allows us to continue to provide better performance per TCO dollar. It's still available in the same capacities that we started with at launch for Apache Pass.
Hmm.
And what's interesting is we thought by this time frame we would have a 1 terabyte device, and we could easily because of the technology. It's such a dense media. But what we learned is that in our first year in market, that customers are still playing in that lower memory space. They're slowly moving up, and that until we have more and more of those fast storage use cases, we didn't need it. So it's
Right.
currently available in the 128, 256, and half a terabyte capacities. Um, and that's the primary differences is the power savings and the performance.
Is the 128 then your most common size footprint?
It really is. It really is. And we're going to be
And
watching that closely because, in the third generation Xeon Scalable, the Ice Lake platform, you're going to have more memory slots. So we're going to have to figure out what does that do to our mix. But yeah, the 128 is most common.
Yeah, I was going to go there next too. So if that's the most common DIM, then what's the most common layout or way customers are figuring out how to balance these versus slot consumption with DRAM and other considerations?
Yeah, it's a great question because some of the complexity of this technology depends on how you size your DRAM cache to your capacity tier. And so I would say the most common is using a 128 gigabyte DIMM, but in the 222 configuration. And what we mean by that is that there is one Optane DIMM and one DRAM in on every memory channel. So it's
Right.
maximally populated. I think that's a unique characteristic of the fact that we share bandwidth with the DDR bus with this technology. And so it makes a lot of sense to use every channel and every slot with lower capacity to maximize your bandwidth. You know, moving forward in when there are alternate ways of connecting, that may change.
Ooh, alternate ways of connecting. So ominous sounding. So I know you guys, and I want to talk a little bit about market segments and where you're seeing some success. I know HPC has been good to you. You had an announcement. I'll let you talk about that earlier this week
Mhm.
on a good success case there. Is the adoption going where you thought it would, or did you learn something along the last year in terms of where these DIMMs or these modules are going?
Yeah, it's such a great question because I feel like I learn something every day. What people are coming up with, as well as where we didn't play where we thought we might, have been just a great journey of learning. Where do I see us, succeeding? I think primarily there are two types of use cases, and one of them would be what I call infrastructure consolidation. It may not be sexy, but there are a lot of people out there who can maximize the amount of work or customers or clients or queries that are done by their existing infrastructure if they balance their core to memory ratio. Those are typically memory mode deployments, and we kind of lead the charge. We're doing a lot of business with virtualized infrastructure, so like VMware and those kinds of cases. Then the other type of use case that we see, and it's where I start to get really excited, is where you're speeding up analytics and time to insights with your data. So taking large data sets, doing the analytics in memory real time using that byte addressable capability, you start to see huge performance benefits. And I would say that we're seeing strength in the finance sector, healthcare, e-commerce, but really anybody who's trying to do real-time processing and analytics on their data, they're starting to see those benefits.
Yeah, well, absolutely. And I think that was one of the things that we said the first time we started to pull some performance data off of these because at launch, I don't know what the pricing looks like today, honestly, but they weren't inexpensive, right? But the
Right.
question is, what's the business value derived from something like an analytics run? If I can do that run minutes or hours or days faster and have actionable insights on that data sooner than my competitors or sooner than we used to, and now we're more efficient. The trickle down of business impact can be really substantial by making what is a relatively minor change in your infrastructure.
Right. I mean, to borrow a slogan from MasterCard, what's the value of being able to process your data real time? It's priceless. I think if you're a trader and you're trying to do real time trading and you're the first person to get the answer that you need from the data and you can make the
Yeah.
trade faster, you win. If you're a credit card company and you're doing real time fraud detection, stopping the action before it happens or as it's happening versus a couple of hours later or overnight, millions and millions of dollars. So video surveillance. What's the other one? E-commerce. A lot of people, or even like TikTok, that are doing video recommendations.
Hmm.
Being able to target your customer, understanding their buying habits, and recommend things that they take you up on, that's priceless too. So, I think those are the types of use cases where these values will trickle down over time.
So tell me about this 10 node challenge that you guys were part of and what you've got going on in that space because I think this is a pretty fun use case.
Yeah, it's really, really exciting. So, I mentioned that the hardware itself isn't a complete solution. You definitely need the software applications to go along with it. And working with one of our large HPC customers, Intel has developed some open source software called Deos. That stands for Distributed Asynchronous Object Store. And what that really is, it's a software-defined, open source, scale-out object store. So it's
Hmm.
pretty modern, pretty, it's really current. It's based 100% on persistent memory. You can't run it with anything else. And what it does is it provides containers to applications that are really high in bandwidth and latency, IOPS or even flops, results in really high IOPS per second. Like many other parallel distributed file systems like Lustre and GPFS, there's a set of software. Part of it goes on the server storage element, and part of it goes on the compute cluster nodes. Um, but it's pretty amazing. And the reason I like to highlight this use case is that we had two of our customers. In addition to Intel, we all submitted the Virtual Institute I/O challenge
Okay.
for the world's fastest file system in the supercompute space. I know that's not every man's technology to have exascale clusters in their bedroom, but I think that it does show the art of what can be done. And it was so exciting to see this. What happened is we took the top three spots in the 10 node challenge, and on the full list we took first, third, and fourth. Um,
Okay.
Now, keeping in mind what is the 10 node challenge? What are these things? These are in the supercompute world. These benchmarks are looking at what is your file system efficiency? What are you really able to provide? And then the 10 node challenge is what if you normalize the number of servers and clients that have to be used to achieve that result? And so the full list, I mean, basically first overall, wow, it was huge. And then with the 10 node challenge to take the top three slots with our customers, we were 3x the nearest non-DEOS solution. So
Oh, nice.
really, really exciting. We're getting a lot of great feedback on that.
Well, I thought you were going to tell me you took first, third, and fourth out of five people that tried, but there was a little more competition than that.
Oh, yes. Yes, this is all supercomputers worldwide.
Yeah, gosh, this whole thing. I never thought I would miss travel as much as as I have this year. As you know, you go to a lot of the same spots, Vegas 7 times in a year, and wherever else these shows are. But Supercompute is one that I always love because it goes somewhere different each year, and maybe it goes back to Denver again or whatever, but it's not in the same spot, so it's always in a different spot. And I
Yeah,
always love just walking the show floor and seeing what people are doing, the universities especially, but even some of the research institutes like NOAA and the space agency and all this other stuff. And I go in and I feel so stupid at that time in my
right. I
life.
know, I know.
But then you go and you say, okay, well, you guys are doing some crazy stuff. What's the underlying technology? And it'll be things like persistent memory. It'll be science projects. It'll be all sorts of things that they're willing to do, to your point, to try to get that next little ounce of performance out of these systems to go solve complex problems. And what we see there, and what we see at events like Open Compute, where you see a lot of new cloud infrastructure being developed and some of it being open sourced by Facebook and others, is neat uses of technology that tend to trickle their way into the enterprise a couple years later and become more mainstream.
Right.
Things like even form factors like M.2 SSDs that are everywhere today, though they were first in some of these places and used in cloud and that sort of thing. So in terms of what you're seeing in HPC, I think it's a great. Obviously, it's real success. It's good success, but I think that will ultimately drive best practices as we move into the enterprise and more common use cases. I mean, I know you guys are already working with a lot of databases. We saw demos with Redis and Aerospike, and I'm sure you've got a dozen more you can rattle off.
Yeah.
But as you think about the mainstream enterprise, what are you seeing there? And is my assertion that it'll get there based on some of these new workloads, is that consistent with what you think or with what you guys are seeing?
It is. It is very consistent. And, I will tell you, of course, I love to spend a lot of time and energy in the innovative spaces like you see in supercomputing and in the universities, because they kind of help you figure out what's going to come in the future. But, we have real customers that are deploying today and already getting value just with what we have. And so sometimes we don't talk as much about them because maybe it's not as sexy, but I have a few examples I can share with you.
Yeah, give us something.
Yeah, so I don't know. Have you heard of SoftBank?
It's an application of some sort, isn't it?
It's a banking company, yeah.
Okay.
And so it's one of the largest banking companies in the world. They actually participate in a lot of venture capital funding new
Right,
businesses.
right,
Like
right.
WeWork was one of them that they were a big part of. But
Hmm.
they're also a communications carrier, and so it's a huge corporation. But they implemented persistent memory for 10,000 virtual machines in their infrastructure. This is that infrastructure consolidation use case that I was talking to you about.
Hmm.
They support approximately 45,000 employees with this infrastructure, and they add 1,000 more virtual machines each year. COVID, I'm sure, accelerated that. So the need for rack space was increasing, and they decided to switch their virtualization infrastructure to a server with Optane persistent memory, and they got 3x improvement in the number of VMs or the VM capacity that they could run,
Huh.
resulting in a 41% cost reduction on the infrastructure required to support their communications business. Um, so they're also now looking at applying it into their other database and multi-access edge computing as they move
Okay.
forward. So
Cool.
one really cool example. I picked another one to talk about they value the persistence aspect of it. So it's Siemens AG. They focus on power generation and distribution, and
Hmm.
they do intelligent infrastructure, and basically they used it to help improve their uptime. They were able to get 15x faster database data load and startup. So every
Hmm.
time they need to take their system down, do maintenance, do patches, the data is persistent, and so it's immediately able to reload when they come back up, and they're able to achieve their 5 nines reliability. So that was
Yeah,
kind of a fun one.
I think that one's a neat one when you think about the time it takes to repopulate DRAM, and DRAM is fast, and I think a lot of people don't think about that. But when you're talking about several terabytes of data, it takes a little while. So if it's there already, that's a helpful bit of the persistent part of the PMem story, right?
Yeah, I was surprised when I joined the team and we started looking at the restart times. Things like SAP HANA, where the memory it lives in memory, it can take
Hmm.
hours to load, and that really impacts your uptime. So I think there really are benefits to
Well,
see
and you've got to
something.
rethink the way you even do life cycle updates on those systems. If you want to go update a NIC or something, and then you've got to spin a reboot, the planning required for that probably gets a lot simpler when you don't have to worry about, like you say, those several hour updates. I also like some of the use cases we're seeing. NetApp is one where they're using persistent memory to accelerate their arrays. So there's the mainline storage business is really interesting. We're seeing a couple different motions where we can just look at the NetApp example. So they're accelerating by putting persistent memory in a server node and sitting it in front of an ONTAP array. And then they're also able to stretch the ONTAP array into the cloud. So now you've got your central hub just like you always have, but now you've got capacity out the back end by going out to Amazon or GCP or whatever to get low cost capacity for tiering out to the cloud, and then also tiering or caching in these high speed persistent memory boxes. I mean that they're definitely on the front end of that, and we've got a MemVerge box that we're expecting in maybe during this podcast, full of technology. Just the emerging companies that are really, well, NetApp's hardly emerging, but the companies that are taking this technology and making it a fundamental part of their product, I'm sure also will drive a lot of awareness into the enterprise.
Yeah, I mean, you've mentioned two companies that we've been working with as far as ecosystem enablement, and I consider them kind of the new innovators for new storage architectures. Memverge, Formulus Black, um,
Yep.
Deos is another example. These are all companies that are built from the ground up, assuming that you now have persistent memory to take advantage of. And it allows you to bring a lot of the storage, traditional storage capability, you do replication, persistence into the memory compute block, and that's where you see the performance benefit. I would say that Memverge has been a great partner. I can't wait for you to get your systems and see what you find out about them. But all of those solutions, the other thing that it brings that I think you can't underestimate is basically its transparency to the applications. So all
Right.
of them kind of act as a shim layer to allow you to achieve app direct enablement without enablement, meaning they've done it for you. So that's the other thing is the application knows how to place the data into the storage tiering where it's appropriate, and you get a great result.
Well, yeah, if you take away the thought of how do I do this and just
Hmm.
consume it in a storage platform that's doing that heavy lifting for you, and you just treat it just like storage and off you go, that may be the easiest way to consume persistent memory.
Hmm.
Yeah, I mentioned cloud a little bit as a tiering, but in terms of a performance component, are you seeing persistent memory as part of instance types in AWS or any of the other major clouds, and what does that look like?
We are working in 5 of the Super 7 with projects of making it available in some type of instance. One
Hmm.
of the learnings that we had early on for broad scale infrastructure as a service is that without app direct enablement, sometimes your performance is somewhat variable in memory mode. And so we weren't a good fit with our first generation for general purpose instances. So what we're seeing is that a lot of the cloud service providers are doing purpose-built instances like SAP HANA instances, database instances, or they're using them for internal use cases. So maybe not for a public service. But that's also, over time, that's morphing. It takes time to get those instances up and running. There's another type of cloud service provider. In fact, one of our customer stories, gPortal, that I was going to share with you. It's an online gaming company. Anything that's SaaS or purpose built, you can start to see some of the same benefits. gPortal, they basically wanted to provide their customers with low latency gaming experience and keep their costs down. And they were able to achieve almost 3 times more game instances per server. So I think for those types of applications in the cloud, that's where you're going to see us getting our toes into the sand as we establish.
If you can solve game load problems, the number of complaints in my household goes down by probably 8 billion% from the 10. I don't I don't know if it's like it must be like this everywhere. The at 8:30 when everyone in the neighborhood's online, the internet's broken. I'm like, it's not broken. It's just
Slow.
busy. It's just busy. So yeah, if we could solve the internet is busy and the Xbox is slow or the group chat won't work or Fortnite won't upload, oh my gosh, that's been the worst part of this whole situation for me.
Yeah,
Which
we're right there with you. We got classes and gaming and work all going on at the same time.
well, we didn't have any classes going on, that's for sure. But we'll we'll see if that changes in a couple weeks. They're going to try to make a go of it. Um, Well, this is really great. I mean, I'm excited about the progress you're making. I do want to make sure though, you've got a lot of web assets, and you guys have a lot of software assets too. I think to help educate people. You've got the PMDK, which is important.
Mhm.
Before we go, will you hit on a couple of those other things? Because I don't want to just only talk about the hardware. That there's so much more to the stack that you guys have available.
Yeah, that's a great question. We actually at launch this year we added 2 new websites to actually help with getting information out there because what we realized is that customers are looking for solutions. They're not looking for a piece of hardware. And we started out with our first launch talking about the product, its speeds and its capability. But we just added this solutions website, and I can get you that link. But basically, it's from a customer. If they're starting, they don't know anything about persistent memory. They can learn a little bit about what it is, but then they can also look at how it's being applied and how customers are doing it. We include reference architectures. We have libraries for the programmers and developers. So really, we're trying to hit assets for anybody and everybody, no matter where they are in that journey.
Yeah, I think the development assets are pretty important as you look
Hmm.
at the next gen of applications or application updates so that they can take advantage of this the right way. Have you had to do much on the infrastructure side? So the server guys, obviously Dell and HP and others were pretty quick to be supporting this, and Cisco and offering it in their builds. How are they coming along with it in terms of understanding what persistent memory can do? Because they're the primary interface for a lot of your customers, I'm sure.
Yeah, they are. And the OEMs are just fabulous partners. I would say that as far as the education and learning, we lock hands together going to market with both training their sales force and our sales force. I'd say it takes time anytime you have something that is as complex as persistent memory. And where they've been, I think, really great partners is we've been trying to develop workload-based solutions with the OEMs that we can kind of help them with what does the architecture need to look like, what does the customer need to do, how do we help them, and then we do POCs with those customers hand in hand. I think that's really working the best, and our OEM partners are fantastic.
Yeah, I do think this is one of those see it to believe it kind of
Yeah.
things until it gets to the point where the system's just, you know, ready nodes or whatever it is are configured with a little bit of this because it just is the best practice, depending on
Yeah.
where you go. And I think too, because you touched on edge just for one single moment and we didn't come back to it, but with all of this growth in edge computing and things like analytics at the edge becoming a bigger and bigger market, we're seeing a lot of use cases where there may not be space for a rack of nodes. You may just get 2 or 3, and that
Hmm.
you still want to have action taking place because data's heavy, and then you've got the whole where do you move it and data governance, and like there's a lot to unpack there. But being able to drive more performance out of these nodes that go into these edge use cases, I think, is a pretty strong growth area for you too.
Yeah, this is exactly what we were made for. I mean, I look at it and, we did a customer POC with a company called Relimetrics and SAP, where they were doing real-time video inspection of their production lines, looking for anomalies if the operators were assembling things correctly. And they were estimating that if they can catch an excursion before it becomes an excursion, that it saves on average $2 million each time something happens, rather
Okay,
than shipping it or calling
that's
it.
actionable. Yeah.
Right? And so we were like, woohoo! And basically they were able to take their small number of servers, increase the memory per server so that they could do that real-time video analytics at the edge right there on the factory floor. They didn't have to go put it in the data center. So really exciting one. Another example of, we were kind of made for that.
Well, yeah, it's great. We've got, like I said, the MemVerge box coming in. We've got Azure Stack HCI with data on with it in there. So
Woohoo!
we're going to go play some more, and we're really looking forward to it. And I'm glad you could come on today and give us the complete story, and hopefully we'll get together in person. I will be out to Portland as soon as you guys are ready. I will be out to Portland because that Hillsborough area where you guys are out there is fantastic. Lots of great things going on out there. Tom and I found a great little bar and cigar shop out there that was exquisite. So I'm ready. I'm ready to go back and check out more of your town out there.
Yeah, we would love to have you.
All right. Well, thanks for jumping in on the podcast today. Really appreciate it. Great to see you and hear your voice again. And thanks for everything PMem related, the Queen of PMem. Thank you.
It was my pleasure.